How you doing? This is Mike here, and in this video we're going to talk about trigonometry and our trig functions. So the first thing I like to do is I like to discuss some of the terms that we're going to see used more often. So I'm going to draw some circles here. So I have my first circle, and then within my circle, I'm going to draw some. Let's see if I can draw this radius that will extend. That's supposed to be a radius. I might have to change this so it's a little bit centered, a little bit better centered. We'll call that radius. Actually, I'll just draw it instead of writing it. And then we'll call another value that extends here, and this will be another leg there. What I'm going to do is that I'm going to denote this value r. So we're going to call this value r, which we're going to say is the radius of our circle. And notice that here between our value of r, between this leg r and between this next leg, we've created an angle. And this angle, we're going to denote this angle, we're going to call this an angle of theta. So I'll denote theta in orange. So theta will be this angle created between this radius, and this is actually a radius as well. We've just actually moved this radius. So and by doing so, when we move this radius, we created this length here. We created this length that we will call an arc length. So right here from here, we're going to call this an arc length, it's actually called an arc. Then the length of the arc is going to be the length traversing from here to here. So this is actually an arc. And we will denote this value. We're going to denote this value. I'll do it, and we'll call it S. So we're going to call this value S. So the length of this arc, we're going to denote S. This angle created between our two radii will be denoted theta, and the length of the radius itself is denoted r. So we can make a relationship here. The relationship that we can indicate is that we can calculate the arc length S. So the arc length S can be calculated by taking the value of r, the radius, and multiplying it times the angle that's created, theta. So that angle theta, but theta must be in radians. It must be in radians. So that begs the question, what is a radian? That begs the question, how do we identify or define a radian? And I know most of us have become much more familiar with degrees, and degrees and radians, they measure the exact same thing. However, they're used differently, sort of like how we see meters and feet. One is a metric version, the other one is a standard English version. So we have different ways to relate these angles. So let's go ahead and define. Define these terms. So first of all, let's make the notion here that we'll say pi radians is equal to 180 degrees, 180 degrees. So every time we see the term pi, every time we say the term pi, we should be thinking 180 degrees. So that would make good sense. So if we were to examine a normal graph, if we were to indicate our axis here, I would call this the x-axis and call this the y-axis. If I were to start my angle here at the x-axis and I were to traverse through quadrants 1 and quadrants 2, I would say this is 180 degrees. So this is the angle of a line, which is equal to 180 degrees, and that was also the same thing as me saying pi. So from 0 degrees here all the way over to here, we call this an angle of pi. And if we travel half that distance, so I'll travel half this distance, we'll do that in purple. If we travel half this distance from here to here, we know this is equal to 90 degrees, and we denote a 90-degree angle by that little half square. We would denote that half of pi is just like what we say is pi over 2. So we can relate our coordinate plane to both degrees and radians. If we want to actually determine these values, that we can say that 1 radian, we divide both sides by pi. 1 radian is equal to 180 degrees divided by pi, which is dividing by that value of 3.14, and that's going to give us a value slightly less than 60 because it's not exactly 3, it's 3.14. So we're going to get, this is approximately equal to 57, I think it's 57.3 degrees. And we can actually even solve for 1 degree. We can make the relationship between 1 degree and a radian, and 1 degree is equal to pi all over 180 degrees, and this is going to be equal to, this is approximately equal to 0.0 Oh, I'm sorry, not 180 degrees. I apologize. It's not 0.017 degrees. I'm sorry, it's just by 180. We say this is going to be equal to 0.017 radians. So we can abbreviate that as rad. So radians are rad. So I often like to indicate some of the more, maybe we could even do a chart. I like to indicate some of the more common terms between radians and degrees that are often used very similarly. So as we just saw here, just by looking at our unit circle, we saw that here at 0 degrees, this will be equal to 0 radians. So this will be 0 radians, and that's our radian. Between here and here, our y-axis in quadrant 1, we create a 90-degree angle. So we have 90 degrees here, which is equal to pi all over 2 radians. Pi over 2 radians. If we keep traveling, and I'm going to do that in yellow, so I'm going to keep traveling in yellow, and we go the distance from quadrant 1 to quadrant 2, this will be equal to 180 degrees, and this is equal to pi radians. This is equal to pi radians. So I'm just going to say pi for right now, not write out radians every time, but I'm assuming that we all know and recognize this is pi radians. So notice here we're adding basically pi over 2 every time, so let's think about this. We'll do some quick math. If I have pi and then I travel all the way around and I add another 9 degrees, which is equal to pi over 2, pi plus pi over 2, because this value here, and I'll do this in brown, this value here is pi over 2, addition of another 9 degrees or another pi over 2 radians, means that I'm also going to have to add another 9 degrees to this value of pi. So think about this as 1 plus 1/2. 1 plus 1/2 is $1.50 or 150, and that's the same thing as me saying 3/2. So we can say this is 3 pi's all over 2, 3 pi's over 2. So pi plus another pi over 2 is 3 pi over 2. And this, ladies and gentlemen, will be equal to 180 plus another 90 degrees. So you're thinking 90 times 3, that's going to be equal to 270 degrees. And then as we traverse one rotation around our coordinate plane, as we travel here through quadrant 1, through quadrant 2, through quadrant 3, and through quadrant 4, we've traveled the entire length of a circle. So we can say that we have extended 360 degrees. 360 degrees, which is the same thing as me saying pi plus another value of pi, which is equal to 2 pi radians. So as we traverse the coordinate plane and we start in quadrant 1 and go all the way around through quadrant 4, we're going to travel a period of 360 degrees, also known as 2 pi radians. There are many other important radians that we can actually discuss, and we can talk about how they're converted. I often like to look at some of the more important angles, especially the 30, 60, 90 degree triangles, also those 45 degree triangles. So if I look here in quadrant 1, I'm going to have a 45 degree angle, which will split my value of pi over 2, which will split my pi over 2 in half. So if we think about this, pi over 2 divided by 2 is going to be equal to pi over 4. Pi over 4. So 45 degrees is the same thing as me saying, pi over 4 radians. So pi over 4 is the same thing as saying 45 degrees. And notice if we want to convert this back, remember we said pi is equal to a value of 180, so we can just take 180 and we divide that through by a value of 4. We think to ourselves, when we divide by 4, that is exactly 45 degrees. So we can go back and forth from both radians and degrees consistently just by substituting the value that pi is equal to a value of 180. Some of our other more common angles for us to discuss is going to be a 30-degree angle. So a 30-degree angle, so that's going to be less. It's going to be less than pi's over 4. So let me go ahead and draw a 30-degree angle in here, and we'll do the 60-degree angle in the same plane. So let's go here and look at a 30-degree angle, and then over here we'll look at a 60-degree angle. So, okay, if we think to ourselves 30-degree angle, that is going to be something divided by, pi divided by some value. Think, what can you divide 180 by that will give you 30? So hopefully we are all recognizing this is going to be pi over 6, because 180 divided by 6 I'm sorry, 180 divided by 6 gives you a value of 30 degrees. So that would be correct. And then if you think about what divided by 180 gives you 60 degrees, hopefully you recognize that that's going to be a value of pi's over 3. So let's go ahead and write that out, that pi over 3 is going to be equal to a value of 60 degrees. Remember, we can find these consistently in any quadrant, 1, 2, 3, or 4, and we have to relate that to our radians as well. So they will change consistently depending upon where you see these angles.